So what we're looking at is section 7.7. This is the last section of the course. And if you've listened to the previous lectures on these sections, I've talked about how taking square roots of negative numbers and even roots of negative numbers was something we couldn't do until later. Well, we will at least look at square roots of negative numbers. And it's with this idea. The square root of -1, we're going to call I. Now, why do we want to do this? And I'll show you, give you an idea of why we like to do this. First off, how does this work for taking, say, square roots of other negative numbers? Well, for example, square root of -4. Now we can write this is the square root of -1 times 4. Or the square root of -1 times the square root of 4. Or I times square root of 4 is 2, and we receive. So this is how it lets us take the square roots of negative numbers. We take the negative, we peel it off as it times -1, and then we break up the square roots as we've learned that we can do. Get I times whatever this square root turned out to be, and we get just 2i, sort of like 2x. So why do this? Well, complex numbers, and this is what we're getting into, is what these are called, numbers that contain this I. They're used in a lot of things. They come up in quantum mechanics. You can use them to describe cyclical behavior. So they're very important, and they're considered what are called two-dimensional numbers. So to give you an idea, is it lets us find solutions to certain equations that we couldn't find solutions to before. For example, this one. Now let's use the quadratic formula. A will be 1, B will be 1, C is equal to 1. So x is -b plus or minus the square root of b squared minus 4ac divided by 2a, which is going to be -1 plus or minus the square root of 1 squared minus 4 times 1 times 1 divided by 2 times 1. Or -1 plus or minus the square root of 1 minus 4 over 2. Or -1 plus or minus the square root of -3 over 2. And this is where we would usually stop. We would say, well, hold on, we can't take the square root of a negative number. But now we can. So we can write this as -1 plus or minus the square root of -1 times 3 over 2. Or -1 plus or minus the square root of -1 times the square root of 3 over 2. Now this is an irrational number, so we're just going to leave it as square root 3. But this we now know is I. And so now we can come up with an answer for this. And so that's going to be our answer. So it lets us do a little more than we did in the past. So let's do some more examples on this. Let's take a look here. So let's say we have something like this. So negative square root of negative 18. Well, this negative is going to hang out here the whole time. But this we can turn into negative 1 times 18. And we could say this is negative 1 times 9 times 2. Now this we can now take a square root of. It's going to be I. We'll also have the square root of 9, which is 3. Again, we can break up our square root. So this will be minus I times 3 times 2, or minus 6. Oh, I'm sorry. Ooh. Square root 2 is still square root 2. Because we can't, there is no square root of 2 that's not an irrational number. So we leave it as that. So this will become negative 3i root 2. Let me just check the format on that question. Let's see. And that would be correct. So that's going to be our answer. Again, we got to keep that as a square root of 2. That was my slip up. All right. So let's say we have something like this. So what we're going to get here is negative 3 minus the square root of minus 1 times 27. Or minus 3 minus the square root of minus 1 times 9 times 3. Or minus 3 minus the square root of minus 1 times the square root of 9 times the square root of 3. Now this is going to be I. This is going to be 3, and this is just going to stay square root 3 because it's irrational. So what we'll get and that's going to be our answer. Again, putting the square root 3 in the back. All right. So before we go any farther, I want to talk about something called the cycles of I. And they work like this. I is the square root of minus 1. Now, I squared would be the square root of minus 1 times the square root of minus 1, which, we're going to get just minus 1. Square root of minus 1 times square root of minus 1 is minus 1. Just like the, square root of 2 times square root of 2 is just 2. Now, I cubed will be I squared, which is minus 1, times I. Or minus I. Now, I to the fourth, well, this is I squared times I squared, or negative 1 times negative 1, and that comes out to positive 1. So what happens now? Well, we go I to the fifth. This will be I to the fourth times I, or 1 times I, which is I, square root of negative 1. We've gone back to the beginning. And so if we did I to the sixth, you would get negative 1. I to the seventh you're going to get negative I. I to the 8th, you'll get 1. And then I to the 9th, you'll get I again, which is square root of negative 1. And we start over. So as we increase the powers on I, we're just going to keep going through these results over and over and over. So let me do an example. Let's say we have I to the 11th. Well, what we could do is we can get a little clever with this. We can write this as I to the 4 plus 4 plus 3, because 4 plus 4 plus 3 is 11. And then using our rules for exponents, this would be I to the 4 times I to the 4 times I to the 3. Now I to the 4 is 1. So this will be 1 times 1 times, and I to the 3 was negative I. So anything times 1 is just that, anything. So we get negative I. So this is sort of a slick trick to figure it out, knowing that I to the 4 is always going to be equal to 1. I to the 3 is always equal to negative I to the 2, or I squared, is always negative 1. And I is just I, or the square root of negative 1. Now, there's another way of doing this. Note, if we take 11 and we divide it by 4, now why 4? Well, there are 4 elements in the cycle. There's I to the 1, I to the 2, I to the 3, I to the 4. So let's divide by that number 4. Well, this goes in at most 2 times. 2 times 4 is 8. Subtract is remainder 3. Now, if you think about this, we found that I to the 11th was equal to 1 times 1 times I to the 3. So what's going on here is this remainder is that 3 that was right there. So we'll still get I to the 3 and I if we replace the 11 with this remainder. So a little trick that helps. We'll do another one. Let's say I to the 253. We're going to do something like this. Well, let's use our trick. The trick is we take 4 and we divide it in the 253 and we look for the remainder. And what's going to happen is I to the 253 will be equal to I with the power, or the exponent, of the remainder. So 4 goes into 25 at most 6 times. Bring down 3. At most 3 times. And we're done. So we get a remainder of 1. So the way this trick works, I to the 253 is equal to I to the 1, or just I. Or square root of negative 1, but I think in the text they want you to put I instead of square root of negative 1. But that's it. Let's do another example. Let's say we have this one. So, excuse me. excuse me, all right. So I do the 46. Again, divide 46 by 4. So goes in one times 4, subtract 0, bring down 6. One times 4, subtract is 2. So this means I to the 46 equals I to the 2, and I squared is -1. Let's double check real quick. Bingo. And that's it. So how is this working? Well, let me show you. So what happens if we divide 46 by 4? We get 11, remainder 2. So what this says is this. 46 is equal to 4 times 11 plus 2 extra. That's what remainder means. So how many times does 4 go into 46? 11 times. There's 11 4s in here. Oh, okay, and then there's 2 extras. Not 4s, but just 2 1s left over. So what this says is that 46 is 4 times 11 plus 2. So that means I to the 46 is I to the 4 times 11 plus 2. Or I do the 4, or we'll do that. I do the 4 times 11 times I to the 2. Or we could write this as I to the 4 to the 11th times I to the 2. Now I to the 4 is always 1. So this is 1 to the 11th times I. 1 to the 11th is just 1. So 1 times I squared. So we'll get I squared or -1. So that's how that's working. Oh, let me see. I think I just dropped that. There it is. So those are the cycles of I. So now what we want to do, let's take a look at just a little bit of sort of the anatomy of these things. So complex numbers, that's what we're looking at. This is sort of the biggest group of numbers that are out there, and they're of this form. A plus BI, where A and B are real numbers. And I is the square root of -1. So what we do is we call A, let me see, is the real part. And we call B the imaginary part. It's imaginary. It has to do with history. Supposedly, in one story that I've heard, and I might have to check on this to see if it's still, this is accurate, it still holds up to evidence, but there was a famous mathematician who saw this whole business of calling the square root of -1 I, and they sort of made fun of it. And they said, this is just nonsense. It's imaginary. This is not real mathematics. Well, we actually use this stuff all the time. Quantum mechanics, for crying out loud, uses these so-called imaginary or complex numbers. So it is something that we do use. And it's also very useful in calculus to solve very difficult calculus problems. So it does have its real life applications. Moving on. But that's how we talk about this. all real numbers are complex numbers. So all the numbers we've been working with in mathematics up till now, they are complex numbers. They're just complex numbers of the form a plus 0 I. So for example, it's really 3 plus 0i. Negative square root of 2 over 3 is really the negative square root of 2 over 3 plus 0 I. So we've actually been working with complex numbers the whole time. We just didn't know it. The I had a 0 multiplied to it. But now we're replacing that 0 with something else. So now that we have some idea of how these fit in, or really everything else fits into them, let's talk about adding and subtracting. So the thing with adding and subtracting is we're basically going to combine like terms, and we treat the I terms like we would combine X terms. So really what we do is we combine the real parts and we combine the imaginary parts. And that's going to be it. So let's do some examples. So once again, let's combine those real parts and combine those imaginary parts. So we'll get 6 plus 4, and then 5i plus 3i. And again, we combine these like if they were 5x plus 3x. We'll get 10 plus 8i. And there we go. Let's do some more. Now let's say we have something like this. Now what we're going to do here, we're going to distribute that minus sign. So we'll get negative 7 plus 5i minus 9. Minus and minus becomes a plus. So plus 11i. Now I combine real parts and combine imaginary parts. Then negative 7 minus 9 plus 5i plus 11i. And if you want, if these were both negative, still put a plus here, and then remember that we do plus a negative, it'll become a subtraction. So we'll get negative 16 plus 16i. So let's do one like that. Let's do one where we have that negative showing up. So let's say we have for minus 3i minus negative 2 plus 6i. Again, we're going to distribute the minus. So we'll get 4 minus 3i, and then we'll have plus 2 minus 6i. Don't need the parentheses anymore. So now we combine like terms. So for the real part, 4 plus 2 plus negative 3i minus 6i. Or we'll get 6 plus negative 9i. Plussing a negative is the same as subtraction. 6 minus 9i. And that's going to be our answer. All right. Now let's see. Well, let's say we have something like this. 15 there. Well, once again, we'll distribute the minus. And combine like terms. Now the real part's just this negative 12. And for the imaginary part, we'll have 15i plus 11i, or negative 12 plus 26i. I'm going to do one more of these. They'll throw some square roots in here. And at least for the ones showing up here, the square roots, they're going to be the same. So that means they're going to be considered like terms. So let's say we have this. Again, we're going to combine like terms, or real part to real part, imaginary part to imaginary part. Now this can get a little confusing. Now these are I terms, so in theory we can combine them. They're also square root 5 terms. So you can think of them like this. This is an I square root 5 term and an I square root 5 term. So we have one of these and 6 of them. Add it together, we get 7. 12 plus 7 I square root 5 terms. And that's going to be our answer. Now, what about multiplication? Well, with multiplication, since these sort of look like binomials, what we're going to do is we're going to FOIL. And often, but let's do some, we'll do one where we don't have to FOIL, we just distribute. So let's say we have this. So we're going to distribute the 5i. So we'll get 5i times 4 plus 5i times 7i. Now, what's going to happen here, though, 5 times 4, think of it as like 5x times 4 is 20x. Same thing here. 5i times 4 is 20i. Now, this one, though, 5 times 7 is 35. But we have I times I. So like 5x times 7x would be 35x squared. 5i times 7i will be 35i squared. So what happens here? Well, remember what I squared means. I squared equals -1. Go back to your cycles of I. I to the 1, I to the 2, I to the 3, I to the 4. I to the 2 equals -1. So we get 20i minus 35. And sort of a convention or a tradition is we put the real part first and the imaginary part second. Minus 35 plus 20. And so that's going to be our answer. Now, whereas talking about FOIL is something like this. So we're not adding or subtracting, we're doing multiplication here. So I want to slip that last example under this header. So let's say we have something like this. So what we're going to do, FOIL. So for first, we have 2 times -3, I'm sorry, 7 times -3. And then 7 times 6i. -2i times -3. And then -2i times 6i. So what we do when we multiply two complex numbers like this, we're going to FOIL them. So now that we've got our FOIL, -21 plus 42i, negative and negative will be positive, so we'll get plus 6i, negative and positive will be negative, so we're going to get -12i, so again, I squared. So this will be -21. We can combine these into 48i minus 12, and don't forget I squared is equal to -1. So this will be -21 plus 48i. Negative and negative will become positive. Combine these real parts. Let's see, -11, -9. And that's going to be our answer. So let's take a look at something like this. Again, FOIL. So 5 times 5. 5 times I root 3. Negative I root 3 times 5. And then negative I root 3 times positive I root 3. what do we have? Well, this is 25. This will be 5i root 3, again, keeping the root at the back, minus 5i root 3. 5 moves up to the front, root goes to the back. I get sandwiched in between. And then this one, negative and positive will be negative. We have a root 3 times a root 3. That will come out to be 3, because square root 3 times square root 3 equals 3. So we've got the roots. Negative, positive will be negative, but we have two i's. I and I squared. Now this works out really nicely. These right here are going to cancel. So this will be 25 minus 3, and don't forget I squared is negative 1, or 25. Negative and negative is positive, where we get 28. Go figure. This times this gives you 28. Well, so it does. So that's what we're going to look at for multiplication. Oh, no, we still got a little more to do. Let's do some more multiplication. Let's take a look at this. So one of the things we could do is, let's say we have this. We have to be careful here. There's a right way and there's a wrong way. Let's talk about the wrong way. So these are complex numbers. So this is going to be something I, and this is going to be something I. So the wrong way to do this, it's very tempting, is to merge the roots together like we've done in the past. So I'm not going to use an equal sign. Let's say we just do this next step. And this part would be equal. And so it looks like that's what this is. But there's a problem here. And let me show you. This is not the answer. No way. Here's why. These are complex numbers. And when you multiply a complex number to a complex number like this, you need to do this first. For I root 7. So there has to be an I involved here. Same thing with square root negative 3. I root 3. So this is what we're going to do. Let's do this again, and let's do this the right way. So this will come out to be I root 7 times I root 3. Using an equal sign and not an arrow. This is a legit way to do it. And then we have the I times square root 7 times square root 3. Or I squared times the square root. Now we merge these to get 7 times 3. Now I squared is negative 1. And this is square root 21, or negative square root 21. Now, when we did it the wrong way, we just got square root 21. So that's why when we work with these square roots, we want to tease out that I. We want to tease out that -1 and take the square root of it. And then we get that I here. So this says we're working with complex numbers. The other method kind of pretends that the negatives actually aren't there. So you want to be careful of that approach. Here, I'll do another one. So let's say we have this. Now again, square root of -9 is square root of -1 times 9, or square root of -1 times the square root of 9, or I. Square root of 9 is 3, or 3I. We need to make this conversion first. Square root of -5 is square root of -1 times 5, or square root of -1 times square root of 5. Here, I'll use dots all the way through. Or I times square root of 5, or square root of 5 with an I in front, because we always put the root in back. So we have this. So it turns out this is 3I, and this is I root 5. So now that we know that, let's do these computations. So we're going to get 3 times I is I squared times square root 5. I squared is -1. Or -3 square root 5. So we want to be careful when we do this. If we just merge the roots right away, we'll cancel these negatives and make it seem like they weren't there to begin with when they really are, because you're not supposed to be able to take the square root of negative numbers. So this is actually very significant that there's a square root and the negatives are there. We don't want to lose that significance. We want to express it in terms of I and then do the multiplication. So the last thing to mention in this section is division. And the thing with division, the key thing, just like we don't typically like radicals in the denominator, we tend to rationalize denominators, sometimes numerators, but mostly denominators. It's very common. We don't want to see i's in the denominator either. So we want to get rid of them. And there's a way we can do this. So let's say we have something like, make this one observation. We did this with square roots, and it's going to work with i's as well. We have a plus bi. We're going to multiply by the same thing, but change the sign. If it's plus, this will become minus. If this was minus, it'll become plus. So again, we FOIL. Now, how does this work? Well, let me show you. A times A times minus bi And then inner will be bi times a, and then bi times negative bi. So putting this all together, we'll get a squared minus abi plus abi, and then this will become minus b squared I squared. Now these in the middle, they cancel. And then this over here, well, what we're going to get is a squared minus b squared. I squared is -1. So we lose the i's here because of cancellation, and then this I goes away because I squared is a real number. So we get a squared, and then negative times negative is positive. Point is this: there are no i's. So the same trick we used with square roots, we're going to use the exact same trick for rationalizing denominators for i's. Now, let's say we have something, let's see here, like this. Let's say we have so 3 plus 4i divided by 5i. Well, there's different ways we could go about this. Probably the easiest way, though, when we have just a term with an I, multiply top and bottom by I. So we don't have to do any fancy rationalizing just yet. So if we do this, we distribute the I. So we'll get 3i plus 4i squared, and then 5i squared. Now remember, I squared is -1. So this will be 3i plus 4 times -1 over 5 times -1. So what we'll get is 3i minus 4 over -5. Or again, putting the real part first, we'll get -4 plus 3i over -5. Now, what will typically happen here, and this is math people being kind of sticklers, we try not to have negatives in the denominator either. We want our denominators very simple. Positive numbers, no negative exponents, no radicals, no i's. So what we can do, we can take this one step further, multiply top and bottom by -1. So this will get distributed in. And what we'll get is 4 minus 3i over 5. So you'll see this done in the book. They'll want you to multiply. If you have a negative in the denominator, multiply by -1. Of course, what you do to the bottom, you got to do the same thing to the top. And that's what you're going to get. Last thing, if you remember that a plus or minus b over c, a over c plus or minus b over c, we want to break this up. So we get 4 over 5 minus 3 over 5. We put the I out like that. Let me double check. Yeah, that's how they're doing it. And so that's going to be our answer. So you have to rationalize the I and also rationalize the negative, so to speak. Let's do another one. So let's say we have something like this. Well, now we're going to use that trick that we used for radicals. So if it's 4 plus 2i, multiply top and bottom by 4 minus 2i. Now, you could use a shortcut. You can say that this is going to be 4 squared plus 2 squared, or 16 plus 4, which will be 20, because that's what we found out. If we took a plus b times a minus b, and if you have an I, that's the big difference. We have an I here. We get a squared plus b squared. So we can use that observation. So what we're going to get on the bottom. Now you can FOIL this out if you want. You don't have to use that trick, but what this means is we get on the bottom 4 squared plus 2 squared. Now we do need to FOIL the top though. Now again, you could FOIL this on your own if you just want to make sure. And you'll get 4 squared minus 2i times 4 plus 2i times 4. So those terms are going to disappear. So you still got the 4 squared, which is 16. And then 2i times minus 2i will be negative 4i squared, or positive 4. And that's what you're going to get here. But we got to FOIL this. So we'll do the first. Yes, 6 times 4. Plus our outer, 6 times negative 2i, plus our inner, and then our last. And just to show that this is in fact what you get, I'll do the FOIL here also. But again, you can use that trick that a plus bi times a minus bi is a squared plus b squared. You can use that, that'll work. But if we did FOIL this, again, first and first, outer, inner, last. So putting it all together, 24 minus 12i minus 12i. And this will be negative, negative is positive 6 I squared. On the bottom. Now on the bottom is where we're going to see i's cancel out. So this will be 16 minus 8i plus 8i. So there they go. These are going to cancel. And then minus 4 I squared. So these here, they'll go away. The I squareds are minus 1. So we get 24 minus 24i, and find some like terms there, plus 6 times negative 1. Now these cancel, so we have 16 minus 4 times negative 1. So we get 24 minus 24i minus 6 over 16. Negative and negative is positive. So sure enough, 4 squared is 16, 2 squared is 4. The shortcut doesn't work. So 24 minus 6 will be 18 minus 24i divided by 16 plus 4 is 20. Now, can we do some factoring? Well, 18 is 2 times 9. 24 is 2 times 12. This is 2 times 10. So we can factor out a 2. And so we get 9 minus 12i over 10. And that's going to be our answer. Let's see. Let's take a look at one more. Oh, I'm sorry, we're not quite done. Not quite. We want to break this up. So this will be 9 over 10 minus 12 over 10i. And in this case, let's see here. Let's double check how they want to do this. Let's see. Yes. So what we're going to get those will cancel. And then that's going to be our answer. All right. So that's pretty much it for 7.7. If any questions, let me know. That's the last section of the course. And yeah, let me know if you have any questions, and well, good luck.